Hey everybody, welcome back to the Metal Mill 52 workshop. Wanted to welcome you. Well, sorry for the loud noise. I've got my air compressor going. It is about a 20-year-old air compressor, and I think it's due for a rebuild with a new valve in it because it's been running about 10 minutes and it's barely gotten any pressure built up. It's reading about 40 psi max output on the compressor. It's a big, let me show you, big 4 horsepower, 25 gallon unit I got from Sears a long time ago, literally like 25 years ago, and it's been good. I've actually rebuilt the valve in it one time. When I ordered that, I got 2, I got a spare. So anyway, hopefully you can see the locomotive right here. And what I've got, that's while we let the air compressor run a little bit more. Got an air line into it, and I've shut the air line off so no extra air will go through there if there's any residual leaks or anything. Got my drain valves closed. It's good. What I'm going to do in a minute, I'm going to open this up and you'll see more pressure on the gauge. Well, you probably won't see it because I'm going to set the camera down, but there's the gauge that shows the pressure. Well, let's open it up now and see what we get. So I just opened the valve here. You see how slowly it's rising? There's just not much pressure coming out of that air compressor. I've been running it a little while. I ran the engine a couple of times when it got up to about 20 psi. That's a good thing that the engine will run on 20 psi of pressure. So it's just I haven't run it since November, since we did the track test. And I took a bunch of things apart, but really hard to tell much with the air compressor in the lousy state that it is, unfortunately. Let's see if I can tilt the camera a little bit better for you. Got my iPhone in a little carrier there. There we go, that looks pretty good. So, we got air, got just about 20 psi on the gauge. Got the Johnson bar in forward here. I'm going to open the throttle and you'll see, excuse me, you'll see the wheels. There we go. So it's moving. Close it, put it in reverse. All the air there is. So very disappointing. I'm not going to let the air compressor get too hot, so I'm going to cut that off and I'll be right back. Yeah, the compressor itself leaks a little bit. You can tell it's warmer here. It's like 73 degrees here today, so that's why I'm happy to have the short sleeve shirt on, t-shirt. And excited to get the engine running a little bit. I've blocked it up. I don't know if you can see this here, but I have it blocked up front and back so the wheels are not in contact with anything while they're running. Let's see. There we go. You can hear a little of the, it has sweet stack torque when it was running with the power on it. So let me see if yeah, not much pressure to go forward. But hopefully I'll stitch these videos. That's only about 4 minutes so far. I'll stitch these together and show you what I'm doing on the pillar tool. I've got a couple of projects. I might as well do it. Let me turn the television down here. You can tell what I like to watch out in the shop. You can hear all the residual leaks. I would assume you can hear that on the video. But here's the pillar tool head so far. Make sure I got this in the frame. I've got a little spring. This is a weak little spring. I put a stronger one. I'm going to need a stronger one on because there'll be a handle and a ball on the end there. But I cut a piece of 3/8 inch drill rod. I threaded it 3/8 24 for the chuck that I'm using here. And I had an interesting dilemma. I noticed that the chuck travel was originally it was only about 3/4 of an inch, and I thought, man, you know, there's going to be times when you're going to want to drill a hole deeper than 3/4 of an inch. So even with delicate stuff. So what I did, I realized the problem was in the orientation of things. So long story short, I basically just shortened the shoulder on it, and I cut a little bit off so that the pivot point sits below the gimbal. I noticed in most of the photographs I saw of this unit, the pivot point sat below the gimbal right here. So hopefully that kind of makes sense. I didn't take exact measurements of any of that stuff when I was doing it, but I did measure the actual depth of the travel on the drill, and I wanted to make sure I had at least an inch. So that's what we have now. We have an inch of travel, and as you can see right here, I put a red magic marker. I just spun this around, held a red Sharpie on there, and then I held it down and spun it around and held the red Sharpie on there so that I could see the travel. Because the next thing I'm going to do is take this all apart, take the spindle shaft out, and then mill a slot in it for the drive disc that's going to go on top of it. That's kind of the next things that need to be done, is mill the slot, make the drive plate, and the drive spindle pulley here. So those are the things I'll be working on. The other thing I'm going to work on is a depth stop. I'm not going to make one for the column here because I think the column itself is limited enough, and I don't want to add any extra pieces in there that would further limit the travel. But page 106 of my book shows a depth stop that can get clamped on here and would have a little adjusting screw that would hit here, so and limit travel. So if you had repetitive drilling operations that you needed to make a bunch that were only the same, small amount, that would be a very handy thing to have. So I'll probably, and you can make those out of 1/4 inch cold rolled steel. So I'll definitely be making one of those for this unit. So that's the intro for today, the upcoming projects. Thanks again, and I will hopefully this will be video one of several that I'll stitch together and make into a longer video for you. Thanks everybody. Hey there, welcome to segment 2 of the Universal Pillar Tool, the Metal Mill 52 latest update. Thought I'd, while I take this apart, show how easy it is. First things first, I'm using pieces of 3/32 inch drill rod, actually pieces of drill, to hold the spring in. I've got some 3/32 inch brass I just found in my supply locker, so I will be using that eventually when we get ready to, maybe at the end of today or tomorrow. I'll cut some teeny little pieces of this and Loctite them in there, because you don't really need to remove the brass, and that's the only 3/32 inch I have. So the only other thing to disassemble this, you take unscrew the little screws in the gimbal head. I'm going to support this because I don't want it to drop out, but just unscrew them. These are the parts I silver soldered last week, and now this clears, and you can actually, I tightened that up, didn't I? I was going to say I can move the gimbal head out of the way. Just use a little adjustable wrench. This is a Baco spanner, which I never had one before, but I like to watch Keith Appleton videos, and he's always bragging about how great they are, and they actually are pretty nice little wrenches. So not that they're a whole heck of a lot better than any other quality made, but I really do. They are quality made, and there's virtually no slop in them anyway. So that's a handy little gadget to have. So I remove that. Now I can twist the gimbal head, and now this part I can unscrew the threaded chuck. That was artful. Unscrew the threaded chuck from it, and I can just lift the spindle shaft out so you can see the 3/8 24 threaded part there. And here's the little gimbal head with the ball bearing inside of it, and it's screwed down, so I can just unscrew that, take that apart. If you can, I haven't Loctited any of this stuff together. I'll do that when I get completely finished, and we'll set this aside. I've got all of these things sitting on the little table. So there's the spindle shaft, there's the little quarter 1/4 inch shoulder here. It's 3/8 inch drill rod turned down on a lathe, and then I tapped it 632 inside there. And the tap paste stuff is great for a drill rod. And if you can see, I do have a little bit more than an inch of travel. I'm pretty excited about that for the drilling depth. I don't know if it comes out pretty clearly on the screen or not, but about 1 1/8 overall depth. And part of the reason I wanted to mark this is that I have to mill the slot. I certainly want to make sure that I go deeper than the travel of the spindle. So that's that. I'll just leave this in here for now and get right to it with this next segment. Hey everybody, welcome back to the Metal Mill 52 workshop. Appreciate you watching this video. I had filmed yesterday, today's Sunday, yesterday on Saturday I filmed a couple of segments that I had alluded to earlier, and you'll be seeing them. You'll have, if all goes well, you will have just seen those segments. But I decided not to splice them in and make them part of this video. I'm just learning the idea of the editing type stuff. And man, they were boring as all get out, and they took forever. So rather because I don't have any fancy editing software, and I don't have any experience doing that, I didn't want to put you all through the boring part. But let me just show you, as I was set up in the mill. This is the spindle for the drill head, obviously, and you can see the drill on there. It's the 3/8 24, and all I did, I put this in the milling machine, trying to get this so the light reflects well for it. But the material is it's a 3/8 inch piece of drill rod, and I machined the slot here right in the center, and it's 80 thousandths deep, and I went ahead and made mine 3/8 of an inch wide, or 3/32 rather. Silly, because 3/8 would be the whole diameter. 3/32 because I didn't have a 1/16 of an inch end mill, and I've had them, and I broke both of them trying to make this little thing right here. So I went ahead and used the 3/32 one and was very careful. It took me 11 minutes, and I had videoed the whole thing, but the video was terrible. You couldn't see what was happening. I was on the mill right over here, and it was interesting to me while I was doing it, but it just took forever. So I thought I didn't want to splice 11 minutes in there just to show you cutting a slot. So anyway, the slot is cut in the spindle for the drill. That's one thing. The next thing I did was I took some 5/16 inch rod, cold rolled steel, and I cut it down, put it to 1/4 inch, put a little shoulder in there, and threaded both ends to 1/4 20. And then I made this little ball handle here out of plastic. I have a chunk of I forget what the name of the plastic is, Delrin. So it's Delrin plastic, and I used my little ball turner, and it started to come out okay, and I thought, I'm going to make it a little different rather than just a round ball, because if you're using a drill, it'd be nice to have something a little, not necessarily to grip onto there, but I went ahead and put these little ridges in there, little grooves, and I polished it up while it was on this. So I made that will go on right here, and so you can see that's what that's going to look like. So I made those parts yesterday, and I also laid out, this is a piece of 1/4 inch steel. I laid it out for the eventual machining operation that I'll do that will make the depth stop for this. So got those things done yesterday, and believe it or not, that took several hours just to get those little things done. Probably took a lot more time than I needed. I screwed up the first one that I made of the ball, and that's why I decided to make this little funky design, because I kind of liked it, and I'm pretty happy with it after all. Also, the next things are the drive pulley and the drive plate. I'm going to show you what I did over here. Forgot to unloosen this before starting the video, but it makes it kind of interesting because you can see it like I'm taking it apart. the drive plate is supposed to be made out of 3/32 inch, 94 thou if you like, brass plate. So I didn't have any, but I did have some 1/16 and some 1/32. So I added those together, cut out these 2-inch squares here, and I epoxied them together with JB Weld, and it's probably going to be a two-handed job. I don't want to pry that up and mess it up. I should have put some wax paper down first, but I'm sure it'll come loose. So that's what I'm going to use as my blank for the 3/32 inch brass plate for the driving plate, and we'll see how that goes. I'll do an update on that in the future. But see, this is kind of thing, that and the little depth stop will be easy to work on during the weeknights. And what I want to do right now, the next thing is I want to put a new valve in my air compressor. You probably, if you remember from the very beginning of this video, that compressor was running. The motor runs great. The tank is in fine condition because I drain the water out routinely. So I'm not worried about that part. But I did need to replace, I may need to replace more than just this, but I found when I ordered the parts, this is I ordered 2 of them is what I'm trying to say. So I had to replace this little, it's not an O-ring, it's kind of maybe you would call it a piston ring for this oilless compressor. But I replaced this one. I knew it was a few years ago, and I found out it was 2006 that I did that. So I bought the compressor in 1995. I remember when and where I was when I bought the thing, and I used it for several major projects, including all the body work, priming, and painting on my 52 Chevy pickup truck, which I've since sold, and I used that money to finance a lot of my other shop additions when I got into live steam. So I replaced that in 2006, and now it's the year 2021, so it's been another 15 years. So I guess, yeah, it probably needs replacement, maybe more than that. So my point is, today's a nice sunny day here on Sunday, and all I'm going to do is to cut a piece of steel here that I think will become the spindle. I think I'm going to actually cut it from this end, about 1.25 inches long, and it will be machined down to the spindle pulley. And I'm going to cut that off in the bandsaw, a little horizontal bandsaw. Then I'm going to take advantage of the daylight to see if I can replace that piston ring this afternoon and get it put back together and test it. And if it doesn't work, if it works great, then I'll put it all back together completely, and maybe we can test run the locomotive again sometime soon. I still have it up on blocks. If it doesn't work, then there is a whole rebuild kit I can get for like $50, which would certainly be worth it. No sense spending hundreds on a new machine if a $50 rebuild kit will work. So that's my little update. Thanks again, everybody, for watching. I hope you found this an interesting thing, and I hope these videos stitch together and make some kind of sense. So next things on the pillar tool will be the little depth stop out of this 1/4 inch steel plate, and the drive pulley, and the drive plate, which will be made out of this 3/32 inch brass plate. And if you notice, one comment, I'm not going to be able to silver solder the drive tang to it, but I've got an idea up my sleeve that will maybe better in the long run, that will be a replaceable unit for that. So stay tuned for more information about that. Once again, thanks everybody for watching the Metal Mill 52 channel. I appreciate it. Keep your thoughts and comments coming, and let me know what you think, what you'd like to see more of, and please pass the word. There are some cool things that YouTube sends me emails that if I got over 1,000 subscribers, that we could do, you know, chat and other features that they'll turn on. And right now I'm sitting around 650 or so. So it'd be awesome if I could get over 1,000 and just see what we could do with the channel. So thanks again, everybody. I appreciate you, and I will keep you posted.